Hello, everyone. It's really great to be here. Really great to have everyone watching live. Just as a reminder, if you are watching live on LinkedIn, please, if you have any comments, any questions, leave them in the comments on the event page on LinkedIn. If you are watching it later, then please enjoy the questions that were asked. My name is Sharif Said Ali. I am co-founder of Nexus Climate, and I am extremely pleased today to have the second speaker in our inaugural sessions on AI for climate. We have with us Dr. Sasha Luccioni. We are extremely lucky to have her today. Dr. Sasha is one of the best known experts on the impacts of AI on climate, and as well as being an amazing research scientist on AI. She is the climate lead at Hugging Face, is a founding member of Climate Change AI, and a board member of WiML Machine Learning. So again, extremely lucky to have you with us today, and it's going to be a fantastic talk, no doubt. It'll go on for about half an hour, and then there'll be an opportunity to ask Dr. Sasha any questions. I'll hand over the floor to you now.
Thank you. Yes, please feel free to ask questions. Please feel free to ask for clarifications if there's anything unclear. I'll try to paint a broad picture, as broad a picture as possible, and hopefully give some examples and make things clearer. So definitely looking forward to hearing your questions or things you wanted me to go deeper in. So my three passions are AI, gender representation in AI, and climate change. Those are like my three main things. At Hugging Face, so Hugging Face is a global startup. We're around 150 people, and the goal is to democratize good AI. So good means responsible, means well documented, means accessible, things like that. And so it's a place that is really fun to work in because it's a really community-based, really kind of like AI for the people. And so in that, in the org, we have an machine learning and society, AI and society team that I'm part of, and I lead really the environmental kind of efforts of that team in terms of models and data sets. And so yeah, just briefly on women in machine learning and climate change AI. So WiML is an organization that aims to promote the work of women. I mean, according to the latest statistics, women represent around 15% of AI researchers, which obviously is not a lot. And so WiML organizes workshops and events and mentorship and things like that in order to help women thrive in that environment. And Climate Change AI is an org we founded, I think, almost 4 or 5 years ago now, that aims to catalyze research at the crossroads of climate change and machine learning. And so today I'll talk to you about the environmental impacts of AI. I want to maybe say the flip side of the coin when it comes to thinking about AI for the environment, kind of what the costs of AI are in terms of environmental impacts. And I'll also talk a little bit about ethics, because it's kind of like the other hat I wear and the other work that I do around kind of the societal impacts of AI. And actually, I find that the two are really linked, and it's really hard to talk about sustainability without talking about ethics, and to talk about ethics without talking about sustainability, because they're really connected, and anything that impacts the climate impacts people, and vice versa. And so the environmental impacts of AI, it's a field that's been gathering momentum since 2019. Some of the biggest large language models specifically, their training has been shown to emit up to 500 tons of CO2 emissions. So for example, for GPT-3, that's around 500 flights between London and New York. So that's a lot for a single model. But actually, training really represents only kind of the tip of the iceberg in terms of the AI's environmental impacts. And so what we haven't seen as much work on is everything when it comes to the idle consumption of hardware, model deployment, obviously, because AI is being used more and more in user-facing tools, experimentation, and equipment manufacturing. And so it's interesting because, like, if we only see that 500 tons above the water, what's the number under the water, essentially? And that's kind of where my work lies. And to give you an idea, last year, actually now 2 years ago, there was this project called the Big Science Initiative, which is actually how I joined Hugging Face. It was a a project bringing together researchers from all over the world to train the first open access large language model. And so multilingual, open access, kind of with the responsible framing. And so my job in the project was kind of to, oh yeah, this is just, it was kind of the biggest large language model at the time in 2022. Obviously now they've gotten a lot bigger. But my goal within the project was to look at the life cycle emissions of the Bloom model, to really like go above and beyond just training and look at look at the AI models from a life cycle approach, which really aims to measure and the environmental impacts of any product, like a pair of jeans or, I don't know, a kilogram of flour or anything, from cradle to the grave. So really, it looks at the whole life cycle of a product. And so for AI, we've been really focusing on kind of the model training part of the life cycle, but there's obviously a larger aspect to it. And so for the big science project for Bloom, we tried to really look at different steps of the model life cycle, everything from manufacturing the equipment to disposal, which is really hard to say for a language model, but at least for deployment. And so when we started looking at equipment manufacturing, for me, it was pretty shocking because, I mean, first of all, there was very little information available, but the little information that was available really showed that producing a single server, so manufacturing a single server for training an AI model, emits up to 2,500 kilograms of CO2. And obviously, nowadays, because AI models are getting bigger and bigger, these servers are also getting bigger and bigger, and like these data centers are getting bigger and bigger. And it's pretty interesting because, you know, that whole supply chain, that whole everything from the raw materials to the energy to the water that's used for manufacturing this equipment really adds up. And so we didn't find any numbers for the exact GPUs that we were using to train Bloom, but we did find some numbers for like similar places that manufacture, for example, hardware, computer hardware. And I mean, there's tons of waste that's produced. There's gallons of fresh water that are used for purifying each little layer of the chip, and huge amounts of energy to connect all the different components. And actually, the difference between, for example, CPUs and GPUs, so CPUs being kind of like the more traditional computing chips that are used for just like your laptop and just kind of general computing equipment, and then GPUs, which were initially conceived for video games, hence the G's for graphical processing. Nowadays, they're used for training AI models because they're highly parallelized. There's a lot of kind of transversal connections within the chip, as opposed to CPU chips, which are more kind of they have less like lateral connections. And so that means that GPUs can be used to process a lot of things in parallel, but it also means that they're denser. They need more, you know, connections made, they need more layers put together. And nowadays they're getting very, very complex. And so that whole process of manufacturing equipment is hugely energy intensive and resource intensive in general. Then we looked at idle versus dynamic power consumption. So typically, when people were measuring the energy used for training AI models, they were focusing on really the GPUs themselves. So really kind of the hardware that is used for the training. But when you look at for example, data centers, if you look at even just like a computing cluster, there's all this overhead. There's a lot of things that need to be connected and running in order for the GPU to be doing the training, essentially. And so we did a couple of tests with the compute cluster where Bloom was trained. We essentially asked them to turn everything off. We were lucky because we had them on the phone. So we told them to turn everything off, then turn on the infrastructure. So essentially kind of like the skeleton of the data center, then to turn on all of the components. So everything like the storage and the networking and all of that. And then finally we did a little test of training. And so essentially we could see that only half of the energy was used by the GPUs themselves, and the other almost half was used by like the rest of the data center, heating, cooling, data storage, networking. And so that was interesting because it kind of showed that whatever figures we did have to date were probably only half of the actual numbers if you consider all of the overhead. And so when we looked at Bloom specifically, we found that the dynamic consumption was 25 tons of CO2. Idle consumption was 11 tons, and then the embodied emissions, so for manufacturing, were 14 tons, and so like 22% overall. My latest work, I've been really digging into model inference, so it's essentially deployment, because it's true that model training might seem like the bigger piece of the pie, which is probably true, but nowadays less and less people are training these big models from scratch, and more people are using existing models fine-tuning or tweaking their models. More and more IoT devices are using AI, and so it's really important to look at the inference, the deployment side of things. And so my recent work, in 2019, the only kind of data point that existed before our piece was that 80 to 90% of NVIDIA's AI workload is inference. So it's a really big chunk of the pie. And so we did this study recently where we looked at different tasks, and we found that for tasks like image generation, for image captioning as well, anything actually using multimodal AI was actually used a lot of energy. And so especially these like larger and larger models, they were getting really quite complex and really compute intensive. And what we looked at was, for example, for Bloom type models. I keep on coming back to Bloom because there's actually very little like fully open source models that you can study kind of all the bits and pieces of. But anyways, we looked at Bloom models of different sizes, and we found that after like 2 to 500 million like queries to a model, you really get the same amount of energy for that was used for training it. And so this might seem like a lot, right? Like 600 million queries, but it's estimated that ChatGPT gets 10 million users a day, sometimes more. And so, if each one of them does 50 queries, you're quickly at training at the training energy. And so, honestly, for a large language model gets deployed and gets used widely, this kind of parity is reached really quickly. And for other tasks like image generation, actually, like just generating a single like HD image, which is like you can see at the top right of the figure, you can generate like something like 1,000 grams of CO2. So it really adds up quickly. And the current work I'm doing aims to go deeper into these numbers and try to figure out, for example, what are the parameters, like the options that can be used in order to reduce these numbers, because essentially that's what we're going for, right? We want more efficient models. We want less compute to be used for the same task. And so I think it's really important to really focus on how to make AI more efficient, less compute intensive. So that's kind of the long and the short of the environmental impact. But now if we go into the ethical issues, because the team I'm part of at Hugging Face, it's really interesting because so Hugging Face has a platform where people share AI models and data sets, and it's like a nonstop kind of all you can eat buffet essentially of models that come that get published by labs, by organizations, and so there's always some new models to study, and that means that we always have something on our plates in order to look at it, to study it, to see if we can break it. And so a lot of the work that I'll present today is kind of informed by that, is informed by having a front row seat to, I guess, latest to greatest or state of the art in AI models. And essentially part of our job is trying to figure out, like, not necessarily, how to, it's not up to us to come up with like safety mechanisms, but it's definitely up to us to figure out how we can document shortcomings, how we can document, ways for which models should be used for eventual biases, toxicity, things like that. So a lot of what we do is really to make sure people are aware of the limitations of the models that they use, so that no one has any bad surprises at the end. And so what's interesting is that even when I joined Hugging Face, 2 years ago now, it was a lot of large language models. It was kind of like, you have a fill in the blanks model, you have a next word prediction model. I mean, it was getting more complex, but still the models were kind of more tangible, more constrained. Nowadays, we have these multimodal models, we have image generation models, image captioning models. It's a lot more, there's a lot more factors at play, which is interesting from a research perspective, but that also means that there are more things to disentangle, because, if you're looking at text only, for example, that you're essentially working with words, but if you're working with text and image, you have kind of two sets of data or to data points to study. And if you have video, then it's even more complex. What if you have audio, et cetera, et cetera? So there's more and more modalities and more challenges somehow. And so we also, we have more capabilities, more complexity, and then also more and more user-facing tools, which essentially, before, like, someone would put a model like BERT up on the hub, and it wouldn't necessarily be used right away, at least in a user-facing application. But nowadays, the latency between someone publishing a new model like Llama and someone using it in a user-facing tool is getting shorter and shorter. We see more and more of like these tools popping up quite quickly, and people kind of plugging these models into different tools almost right away. And so that also means that there's less time for people to discover any potential issues or like potential ethical issues, and more kind of chances that there might be misuse. So starting with data, that's kind of the starting point for a lot of ethical issues in AI models. Data is getting bigger and bigger, right? We're using more and more data to train these models. So more data, more problems. A study that I led in 2021, we looked at textual data, and we found that there's so much just like hateful and toxic content that's getting used to train AI models, textual AI models, and it's so hard to filter it out because there's all sorts of kind of latent implicit biases. There's all sorts of like, there's so much weird stuff on the internet essentially that it's really hard to really filter it out even using keywords. So we tried to use different approaches and try to filter out using these different kind of classifiers and keywords, et cetera. And we found that no matter what we did, there was always some dark stuff left. And essentially that's kind of part of the issue is that it's really, really hard to filter this stuff out when you're training AI models. Another study that was done around the same time showed that there's also a lot of copyrighted data and data that, like for example, patents on Google that's not really meant to be used for training AI models, like websites like the New York Times, like a lot of media, a lot of scientific articles. So essentially, on one hand, you do have this kind of toxic content issue, questionable content issue, and on the other hand, you have copyrighted content, which is shouldn't be in there, but it's also really hard to remove because in a lot of cases, for example, Jesse Dodge and his team, they actually looked at the metadata, but because they did this experiment, right? But in a lot of cases, you just have the raw text, and it's actually really, really hard to track down where text is coming from. And so that at the end of the day, there's stuff going into these models that shouldn't be going in there, and that can cause problems down the line. There's also the human costs, which is probably something that doesn't get as much media coverage. Essentially, for me, the big kind of change when it came to, for example, ChatGPT, which is undoubtedly a leap forward in terms of capabilities of AI models. But what's interesting is that we know very little about ChatGPT. Please don't ask me what the carbon emissions of ChatGPT is because we don't really know. But what we do know is that there was this technique that was developed around that time that's called reinforcement learning from human feedback. And so this makes interactive models. So as opposed to like the BERT model that I showed a couple of slides ago that could only predict the next word, you have these models that can really respond, right? It can respond to an instruction. You can tell it, tell me, I don't know, write me a poem or tell me a joke, and it really responds to your kind of prompts. And essentially what makes these models so interactive and so human-like almost is that they're trained for thousands of hours based on human feedback. And essentially how this is done is that once the model has been trained on this raw data from the internet or from books or whatever, it then gets, the model then gets set up in a human interface, like a UI, where human crowdsource workers will actually interact with it, and they'll have either certain instructions to give it or certain topics to train it on. And for example, I'll ask a question like, I don't know, give me a recipe for a chocolate chip cookie. Then the model will generate a recipe, and the human will fix the recipe if there's things to be fixed in there. For example, if there's too many eggs, not enough flour. So the humans are actually continuing to train the model offline. It's no longer kind of the compute, GPU training, but it's human training, and that's what's making these models so good. And so that means that a lot of this machine intelligence, this really kind of groundbreaking intelligence that people have seen in ChatGPT, is actually due to human feedback. And so there was a couple of studies. There was a Time magazine one. There was, I want to say MIT Tech Review. So there was a couple of studies that really showed that there's a lot of kind of underpaid human labor that goes into training these models, and that actually, it's an ongoing process. Also, there's like a constant struggle to make them more safe, less toxic, more responsive to current events, right? Because an AI model that was trained last year won't know what's going on this year. And so there's also like an ongoing kind of group of workers around the world that are doing this work. In terms of bias and representativity, it's interesting because, I mean, there's a lot of these studies that come out like this. There's this really big ProPublica study from a couple of years ago about machine bias that, it's interesting because it's like almost playing catch up. Like these models get deployed in society. This is like the study actually looked at sentencing AI models that were like used in the criminal justice system in the States in order to assign essentially risk scores to criminals, and essentially to predict how likely they are to commit a crime again, essentially. And so what it found, the study, this was like on good old fashioned like classifier type AI models. It was found that they're extremely racist, extremely like biased depending on like postal codes and things like that, and essentially that a lot of these models that were like actively used by the justice system were actually, biased towards, for example, people of color. Nowadays, it's actually a lot harder to find these kinds of biases because, when it comes to, for example, a model like ChatGPT, it's really hard to even give a hypothetical, like, here's one criminal, here's another criminal. Like, first of all, they're not built for this kind of prediction, but also, it's almost kind of very artificial. It's like trying to put the system in a use case that's not built for. And so people have been doing other things, like, for example, asking ChatGPT to write a Python function, a computer function, to see if someone would be a good scientist. But what they're finding is that different kind of biases, but there are biases in these models nonetheless. And so, for example, ChatGPT responded, if race equals white and gender equals male, then someone is a good scientist, right? And so people are being a bit more creative nowadays for finding these kinds of biases, but they are still there. They're just kind of harder to get to, especially for models that are, behind a user interface that you can't really kind of download and play around with. And so what also this can lead to is, so for example, ChatGPT, like in this case, you can say, oh, it's just a Python function. It's just a computer program. It doesn't really have like real world impacts. But the thing is that people are building upon these models and they're using them to create, once again, user-facing tools. So someone actually developed what they call the forensic sketch AI artist, based on DALL-E, DALL-E 2, which is the OpenAI image generation model. And so essentially they're building a UI on top of this, building a use case and a tool on top of a model. And for example, using it in a kind of a similar context as the criminal sentencing context, except for generating sketches of potential criminals. And so you can imagine that all these biases that are like baked into these models will come back to the surface when you have, like, for example, you say, oh, this is a dangerous criminal, and the model will generate what it represents a dangerous criminal to look like, and this can of course influence people's behavior. Oh yeah, that guy looks like the person who assaulted me last night, but it's kind of a self-fulfilling prophecy, right? It's not like the bias of these models then gets kind of operationalized in the criminal justice system. And so that's also particularly dangerous because it's even harder to kind of open up the black box and figure out where the bias is coming from. Is it the person themselves? I mean, all people are biased, of course, or is it the model, or is it kind of the interface on top of the model? And then it kind of quickly becomes very, very difficult to disentangle. So in the last couple of minutes, I want to talk about what we can do. I mean, it's not all bad. There's a lot of things that we can do that are already being done, and hopefully might give you ideas of things that you yourself can do to work on AI sustainability, AI ethics. Because I often get people who reach out to me who say, well, I want to get started. I work in a startup, I work in data science, I work in whatever engineering, and I want to kind of get started in this kind of field. How do I do it? And of course, it's not telling people to quit their jobs and go do this, but it can be interesting to do projects, to do hackathons, to do just like side kind of hobby things to explore this field and to kind of give back or contribute. And so something that I'm actually a huge believer in are model cards. So model cards are ways to document AI models in order to essentially say how they've been built, and also how they should and should not be used. And so there's different kinds of flavors, different kind of things that people include, but everything from like model training, the data that was used, technical specifications, environmental impact, of course, like all sorts of things. And you can also have evaluation results. So once you've trained your model, you evaluate it on specific data sets, and you can report that as well, because there's so much noise in there. I mean, actually, it just moves so quickly that it's really hard to say how good a model is unless essentially you have a scientific report or a paper. But showing that information is really important. And of course, environmental impacts as well are really important. And this is something that we've been really trying to promote on the hub. So when someone trains a model, instead of just being like, oh, here's my model, do whatever, really documenting how the model was built, where the data was sourced from, how long it was trained for, et cetera, and to give all this information to people so that they can make informed choices around like, oh, this model is meant to do the task that I want to do. In terms of image generation bias, so when the first Stable Diffusion model came out on the hub, we were all kind of like trying to scramble and figure out a way of evaluating it. But of course, it's really hard to say this is a racist model, this is a sexist model. There's no single right answer to any of these questions. And so a project that I led last year is called Stable Bias. And so essentially what we did is we looked at professions and we looked at different image generation models, and we tried to show how for a given profession how the images generated differed, and without saying like all models, all images of CEOs should be like this, or all images of librarians should look like that, but just to show that this did differ. And so depending on your particular use case, what you want a model to be good at, you can choose one model or the other. And so this is like, we created this Explorer tool where you could like compare two different models. So here it's Stable Diffusion 1.4 and DALL-E 2. And for like a profession like firefighter, you can see how the images differ. And you can also, we actually added adjectives as well. We found that adding certain adjectives like gentle would actually make more women appear in the images, where like women, of course, people with visual characteristics that could make you think of women appear in the images generated. And I also worked with a team in Germany to try to create fair Stable Diffusion models. So to essentially do guided generation. So in certain cases, maybe it's not an issue if all of the firefighters generated are male. But in other cases, maybe if you want to do, I don't know, a campaign, an advertising campaign where you want to inspire, young women to get involved in firefighting or whatnot, then you want more diversity to appear in your images, right? There's different use cases for all of these tools. And so essentially we helped develop a technique that could help guide these image generation models into directions that are of interest, that are of essentially that are contextually important. Also, something that I'm particularly proud of on the Hugging Face website are leaderboards. So essentially, they cover different metrics. So typically, people are like, I'm going to use this model because it's the best. Like it has the best performance on whatever data set. But often there's more to it than just performance. So for example, performance and efficiency, right? So if just because a model is 5% higher accuracy, but if it uses a lot more energy, if it's a lot less efficient, maybe that 5% doesn't matter as much, and maybe there's some middle ground between the two. And so we have a couple of leaderboards where people can look at different models and compare them in terms of latency, in terms of performance, in terms of different hardware, et cetera. So I find that it's really useful because for a lot of people don't have unlimited compute and actually need more frugal models to do the same kind of tasks. A project that I'm currently pursuing is to develop AI Energy Star ratings. And so essentially, this is kind of concept that exists in different European countries, in Canada and the States. It's essentially a way of benchmarking different appliances, different buildings even, based on their energy efficiency. And so you've got kind of these standardized measures for buildings of different categories, for data centers, for computers, for phones, for washing machines, et cetera. And so I'm working to develop kind of similar things like this for AI models of different tasks. So if you have an image generation model, is there, if you just establish a range of energy consumption, then you can say, well, this model is relatively more or less efficient in image generation compared to other models. So hopefully ongoing in the next month or so, we'll have some first kind of results. In the very last minute, something of a conclusion. I mean, I know you saw the talk a couple of weeks ago, and I agree that AI does have a lot of potential to tackle the climate crisis, but it's also kind of part of many different solutions. So by itself, It's definitely not going to solve much, but as part of a contextual kind of ecosystem of solutions, it can definitely have impact. And also, like a lot of the models I showed today can have pretty big environmental footprints, but it's definitely not the case for a lot of climate positive applications. They're actually pretty efficient. They're actually pretty low carbon. But in any case, it's important to compare costs and benefits. And that's actually how I got started in this field. I was doing kind of climate positive work, and then I realized that I didn't have a meaningful way to calculate the carbon footprint of what I was doing. And so I really wanted, as a scientist, to be able to make those trade-offs to say, okay, well, this is what I'm aiming to save in terms of climate, but this is what it could cost in terms of energy or greenhouse gas emissions. And so I'm a big believer in transparency. So once again, maybe not everyone cares about environmental impacts, and that's fine, but just giving that information to people, especially as more AI tools get deployed, is going to be really, really important, just so people can make informed decisions. Like if they care, they can use this information in order to choose a model. If they don't care, it's fine, but still, at least that information is out there. And so as kind of part of the AI and society team, I think that innovation is really important. And I mean, Hugging Face is all about kind of responsible innovation, but we really do need to have more safeguards, more transparency, more mechanisms to frame AI in a broader context of its impacts on society and the environment. So thank you, and I'm looking forward to answering any questions that people might have.
Thank you so much, Sasha. It's yeah, absolutely amazing to hear about everything that you've been working on, both kind of as a researcher and through Hugging Face. And of course, it's amazing to see kind of all the efforts that are going on within Hugging Face, given that it's one of the most most important really AI platforms out there. And I've just kind of there's a bunch of things I wanted to ask you maybe first before getting into other questions. But one thing that you kind of talked about a few times in different ways is kind of looking at the LCA, the life cycle assessment, looking at the sort of when you're training or using an AI model, how much is going into that in terms of energy, where the energy is coming from, but as well as kind of thinking about that whole everything around that. So I've never thought about the idle state of a data center, for example, and then obviously things around hardware, kind of environmental impact of the hardware manufacturing, and all of that is something that we often don't think about. And kind of linking that to your last point on transparency, which is absolutely incredibly important. How do you see, for example, a future where if I'm a consumer using ChatGPT or Claude or any other or Stable Diffusion, I get some sense of what's going on in the background, of how much my activity is emitting in effect.
Well, that's why I'm working on these AI Energy Star ratings. I mean, currently we're gonna definitely work on the open source models that we found is on the Hugging Face hub. But definitely, like, I've been talking to Google, I've been talking to Cohere in order to test their models as well, because ideally, right, also you need as many data points as possible to establish a range. And so ideally, when we test a bunch of these models, we'll be able to establish this range. And also, I think that like maybe incentivize people to, people like gold stars essentially. And so incentivizing people to be striving towards having like A+ models. That's kind of my goal. And I think that, just maybe there's this definite, I guess currently there's a bit of a secret, going on in AI, just because people don't want to essentially lose their competitive edge. But if you do establish like a standardized way of testing that doesn't put people's business model, like I'm not asking for access to Claude, I'm not asking for access to ChatGPT, but just like having a way of testing them, I think it's definitely kind of, it can speak to these companies and it can help like a lot of the companies like the big tech companies do have ESG commitments, right? And so this can definitely be part of those kinds of commitments or those kinds of goals.
Yep. And sort of maybe sort of moving on from the emission side to more the some of the things around the copyright issues, and perhaps maybe because I'm thinking obviously we want we want to have, if it's language models or image generation models, the more capable they are, perhaps the better they are in many ways, although obviously the bigger they are, also the kind of seeing from your table, the inference, in the amount of emissions involved in inference increases as well with the model size. But to what extent, are there any sort of efforts going in terms of trying to solve that copyright issue, to try and kind of have models that are trained on really good data but aren't infringing on copyright?
I think that currently there's a bit of a pushback, like for the longest time. I mean, as long as I've been kind of working in AI, and there's been this whatever. Let's not even worry about the copyright aspect, because it was kind of this widely accepted idea that it's not an issue, that training AI models is fair use, essentially, because, and especially in the States, there's this idea of that if you're doing making a derivative of something, that essentially if like I'm remixing a song that's completely different, I can use bits and pieces of other songs because it's fair use, because it's a new thing. I'm like a new artifact I'm creating, even if it's the bits and pieces of other people's work. And so that's been typically fair use. And so people have assumed that AI falls under the fair use category forever, essentially. But nowadays there's more and more pushback, like artists are suing, creators are suing. And I mean, we don't have any good precedent yet about like when is it fair use, when is it not fair use, because it's really, there's a lot of kind of technical questions in there as well, like do large language models memorize? How many examples of a data point have to be in a data set in order for the model to actually kind of be able to reproduce that exact image? Like, I mean, there was some interesting work actually out of Google about on image generation models that found if there's like a certain number of portraits of Obama, the model could actually generate the exact portrait of Obama that was in the data set. And so I think that there's a lot of like kind of technical issues, there's a lot of legal issues, and there are people doing work that are really like, instead of asking for explicit consent, like to opt out, which is kind of technically like, oh, well, if you have an issue with your data being in the data set, you have to, it's up to you to contact me and tell me that you have this issue. Now people in some orgs are adopting the opposite approach of only creating opt-in data sets. And so, for example, for Blue, for Big Science, we essentially curated this, like the data set was smaller than like most web crawl data sets because we were a bit more, I guess, informed. But still, like we reached out to communities asking them whether we could use their data, like I think the British National, like the British Library actually, like we actually reached out and then we developed a way of using the data in a way that essentially, only certain documents or only before a certain year, et cetera, in order to kind of establish a clear legal basis. And we even developed specific licenses that weren't like, whatever, MIT, that weren't Creative Commons, that were actually specific licenses for AI, the responsible AI license, for example. And so I think it's interesting because on the one hand, it took a lot longer than just scraping the internet or downloading like the whole of the internet. But on the other hand, it helped develop new mechanisms. It had helped develop new tools for kind of a more responsible data usage and model training in the end. And I think that like it's still an ongoing like question. Like people have been like, oh well, there's this new use case, or the responsible AI license doesn't really cover like my particular. So for example, I was talking to someone recently who wants to help preserve indigenous languages, and they want to train models without giving up the licensing of their own data, because that data is very precious to these communities. And so it's like, are there ways of, giving some usage of the data without giving up complete agency? And it's really interesting because I think that there's a lot of use cases and there's a lot of potential solutions to these use cases.
Yeah, it's very interesting because also, partly exactly for a use case where you need, and the more kind of narrow the use case is, or the more kind of quite specific it is, the more you really require that data to be able to make use, to get to a model that is actually useful, and that in a way requires you to give up some of your rights, or at least give away some limited portions of your rights.
Mm-hmm.
I do always wonder if sort of around the proprietary models versus open source models, whether more people would be more willing to have their data used for open source models rather than for proprietary data. But I don't know if you've seen anything around that.
I mean, I think there's this really interesting debate going on about open source versus proprietary. I definitely think it's not like an either or situation. I think it's more of a, one of my colleagues, Irene Suleiman, she published a really interesting paper about like a gradient essentially between closed source and open source. And it's true that even, for example, Bloom is not technically an open source model, it's an open access model, because open source comes with specific it's like a specific term that means a specific thing. Like the code has to be accessible, the data has to be completely accessible, and the weights have to be accessible. So sometimes you can have one of the three or two of the three and not all of the three, and that's fine. And I think it's interesting because we're currently seeing, even like, for example, Meta, Facebook, who have been very transparent, like they've been publishing almost all of their most recent models on Hugging Face and generally. But sometimes they can't share the data that was used to train the model, but they can share the model itself, right? And so it's like, it's really interesting because we're seeing even like big tech companies who do have a lot of constraints, right? Like they do have sometimes, I don't know, like user-facing products. They can't necessarily share like everything that they use, but they are sharing certain aspects, certain artifacts. And I think that we're living in a really interesting time because like industry and academia are trying to establish a way of doing innovative AI research and building upon each other's research, because that's kind of the point of research, I guess, is to incrementally, right, improve upon the current state of things. And I think that a lot of big research labs want to continue building upon each other's work, but without losing their competitive edge or their competitive advantage. So I see it as a really interesting kind of like trying to figure out what's the mechanisms that make everyone comfortable.
Yeah, it's extremely interesting how it's evolving, particularly kind of looking at the generative AI and how kind of different companies are approaching the release of different models. Just saw recently also that Apple released a very detailed paper with weights and all sorts of things released publicly, which was quite interesting as well in the scheme of things, given that their business model as well is quite different from a lot of the other big tech companies.
Mm-hmm.
So kind of maybe going to your question, going back to your experience with Bloom, but kind of more broadly, I guess, how would you kind of, in terms of the use of different energy sources in the running of the data centers that are running these models, either on the training or the inference sides, but has there been like obviously, on one side you could say, okay, it's all renewable energy, and presumably, at least in some ways, the emissions from the electricity are close to zero, although it's never quite that. And on the other side, you have something running completely on coal power, for example. But is there like I don't know if you've seen sort of any convergence, at least from some of the big tech companies towards using more renewables, for example, or
definitely 100%. The thing is, I think actually, once again, big tech companies have been building this out for several years now. I think that nowadays there's more pressure, like there's more demand, so it's harder. Like you can't, like one data center a year isn't going to cut it because there's so much more demand for like customer facing AI. So definitely it's kicked things into high gear. What I've seen is that the thing is that for like short-term capacity building, it's cheaper and it's more accessible to build in places where there's already data centers because the infrastructure is already there, right? So, for example, if you had to build a data center by the end of 2024, building it in a place where you don't have any existing computing infrastructure is really hard because you have to like buy the land and the groundwork and like do the internet and everything. And so I think that building out to new places, for example, that are powered by renewable energy might be like more of a medium to long-term goal, but that is being worked upon. And in the short term, we are seeing more like the hyperscale data centers are being built in the same places where there's already hyperscale data centers because of just the facility of like connecting the different infrastructure. So there's this place in, there's a region in Virginia in the United States. It's called Data Center Alley because there's so many of these data centers, and we're seeing it like growing like quite quickly every year. But there are projects, for example, in Quebec, Canada, where I'm based, has hydroelectricity. There are like kind of more like long-term projects to build out infrastructure. But the thing is, for example, I know that in Quebec particularly, we're already reaching capacity in terms of the existing dams that we have. And so we can't build 10 new hyperscale data centers unless we build a new dam. And of course, that comes with environmental consequences as well. And same thing goes for places that have, I don't know, wind or solar. It's the same thing. If you want to build a new data center that requires a lot of energy, you have to build out capacity first. And so it's really kind of like a chicken and egg situation.
So I think what's very interesting is that even though obviously there's the every big company, every big tech company has made quite significant climate pledges, and there is definitely significant investment going into green energy there. But at the same time, the point that the demand for the AI side of things means that you have a lot more being built before that renewable generation, that clean electricity generation being possible. And that delay is quite significant, potentially quite significant in terms of the climate impact of these models. And I'm wondering whether, I mean, in a way, like, kind of your thoughts on the really looking at the use case versus the potential impact. And obviously, on the potential impact, first of all, you need the transparency, and kind of obviously the work you're doing on the Angie Star rating is really on point on that. And then on the other side, like, because every company in the world is experimenting with machine learning at the moment, with AI, is experimenting with generative models and so on, which is totally understandable. And you probably, as a business, you have to do that. But there's a point at which when you say, okay, actually, should we be doing this, particularly if you're having as a company or as a public sector entity, you have quite significant climate pledges that you've made. Like, how do you say, okay, actually, this use case is justified from a climate perspective, or is not justified?
I mean, it really, I think that it's difficult if you're using existing tools that don't necessarily share the information. But if you're building your own infrastructure from the ground up, like, for example, if you have a significant project and you're going to buy some X hours of compute from a provider, or you're even going to build your own compute cluster, I think that, like, the more essentially control you have on the different steps, the more you can ask for transparency. Like, I know that if you're using like AWS or whatever, you can say, I want, like, I helped kind of implement this at Hugging Face. Like, we signed for, like, we created a cluster with that. Like, I mean, not an on-premise cluster, but like a cloud cluster for training our models. And we said that we wanted it to be in a low carbon emissions zone, which is right, like, because it was a certain amount of compute, we were able to do. I think that maybe if you have like smaller processes you run, you maybe have less control. But once again, if you're building a cluster, then you can also like control where it's being built. If you're using someone's like deployed model, once again, you can ask that it's running in a certain area. If I don't know, you can also, like, the more, if it's like an in-house on-premise solution, you can also, like, so I helped create this slight parenthesis. I helped create a Python package called Code Carbon, which essentially estimates the energy usage of any code, including AI, and you can use it in order to benchmark models. So you can essentially test, until my AI Energy Star project is off the ground, you can test different models and say, okay, well, this one is actually more energy efficient. And so, like, if you know what your end goal is going to be, if you know that, like, how many clients you want to serve, or whatever, what the infrastructure is going to be, you can actually really, like, completely control for the energy usage of the tool. So I think that there's, like, kind of small things you can do along the different steps of the life cycle in order to make informed choices. But of course, if you're using like a black box model or like an API that you have absolutely no transparency into, it's really hard to be like, hey, company who's offering me this tool, to give me more information when the information is just not there.
So I think what's really important there is that if someone it's in a relatively large enterprise company that is deploying AI at some scale, where they have building a cluster or kind of at least renting out a decent amount of server space, that they have some control, they have choices that they can make that can make them, at least that deployment, their usage, a bit greener. And whilst obviously in the aggregate you need everything to be greener, because it's just displacing one thing, and essentially if you have the same limited amount of green electricity going into server farms and so on, then it's not going to be great. But the more demand there is from the consumers, in this case corporates, then I guess there's going to be more pressure for faster deployment of greener data centers, which I think overall would be very good. So in a way, I think what's very good there is that there is a consumer power there that can drive a faster move towards greener.
Yeah. And I think that if people start asking for this, like people don't essentially realize how much power they have as consumers or for any kind of product. Like you really have power by the things that you use or buy or don't use or don't buy.
Yeah, and absolutely, and kind of me just as an individual as well. If I had like okay, like there's like if there's 3-4 LLMs or kind of chat-based LLMs, LLM-based chat engines that I could use, all of them are of decent quality. I would go with the one that has a significantly lower carbon emissions, quite if I knew about that, and if there was obviously the sort of some kind of a baseline, something that's objective classification of those, which is kind of again where really kind of the things like the energy star system that you are working on is I think would be absolutely fantastic for.
Yeah, and I agree that, I mean, for example, there is regulation that's aiming to shed more light, or even to say that models have to be this efficient in order to be deployed in this region. But I think that at the end of the day, like legislation moves slowly, which is kind of okay. That's kind of the way laws are supposed to be written. But that's why like user pressure can be a more short-term lever for change, as opposed to like waiting for the laws to catch up.
Yeah, and perhaps actually, so I should have one final question, which is came to me via WhatsApp, and it's really to do with regulators. How do they? How do you think they can become more up to speed with what's happening within AI, with sort of some of the technical underpinnings of issues, whether it has to do with bias or with copyright or with the climate impact, to be able to make the right sort of the better decisions faster? This is obviously a sort of not something that has an easy answer, but kind of if you have I've seen any good examples of this happening.
So there's something that exists in the States that I wish existed in other places, which is essentially kind of like this year, like for example, someone like a researcher working in AI can spend a year at the White House at the Office of Science, Technology, and Policy. Essentially, and it's only like a fixed term. Like you can only, like for example, if you're a professor, you can spend your sabbatical at the White House advising them on specific issues, and then you have to go back. So I think that the thing with any kind of policy making is that as soon as you leave whatever field you're in and you're immersing yourself into policy, it's really hard or impossible even to continue being aware of whatever's going on. And so having this kind of fixed term position, I think is a way of having always like the latest, like people who are aware of the latest trends advising policymakers. And we don't have that in Canada. I've never heard of it in other places. I mean, sometimes there's like committees or things like that, but like this whole spending a year full time helping advise policymakers is really powerful. I think it's more powerful potentially than just like sitting on a committee or advising kind of like part-time. So I wish we had that in more places. And in the meantime, I mean, I think that depending on where people are situated, there are ways of getting academics. Like I'm always like telling people in Canada, like invite me, like I will come give a talk and I will try to explain this to you in like the most accessible way possible, just so, because it moves so quickly also. And there's sometimes like, there's a lot of like, for example, nowadays when we talk about AI, most people assume we're talking about large language models or ChatGPT, chatbot type AI, but there's so much more to it than that, right? And so sometimes just having someone to remind policymakers of like, hey, you think you're legislating chatbots, but you're legislating chatbots and a lot of other things that are not necessarily chatbots. And so definitely connections between research and policymaking is a really big thing, and developing more programs like the OSTP.
Yeah, and it's I mean, I've heard a little bit about it before, but it does seem like a really, really good example of a way to bring in research and science very, very close to the policy making and the political decision making. I think it's also incredibly important that policy is based on a deep, or at least a decent, at the very least, understanding of science and technology.
Mm-hmm.
Sasha, so just want to before we end, I just want to see if we wanted to add anything.
No, I mean, thank you for having me. And if anyone has any other questions, they can always send me an email or LinkedIn message. I'm always happy to answer more questions.
So thank you very, very much. It's been an absolute pleasure to have Dr. Sasha Luccioni with us today. Sasha, thank you so much. Have a great rest of your week.
Thank you. You too.
Thank you, everyone, for being here. Goodbye.